In this lesson, we're going to take a look at elastic potential energy and the work done to stretch a spring. So elastic potential energy is an interesting concept. Elastic is exactly what it sounds like. We distort something from its original shape and it wants to come back to that shape. When we do that, to stretch it, it requires work, right? So in lab, you guys used a spring and you stretched that spring, and as you stretched it, you had to apply more and more force through more and more distance. But that work that was done to stretch this spring isn't gone, right? This spring is now storing that energy. It really wants to return back to its original shape. So in this state where I've done work to stretch it, I've transferred energy from myself into that spring, and now that spring is storing that energy. So elastic potential energy is energy stored in a spring or a rubber band or anything else that we can distort, right? So that's what we mean by elastic. We can pull it from its original shape. Now, what's interesting about this is how we actually get there and its relation to work. Okay, so we're going to come up with this new definition of work. Work is the transfer of energy. Now, if we think about what that means, okay, like I said a minute ago, that's because when we do work to stretch this out, we're exerting a force through a distance, right? And the force and the displacement are in the same direction. And the more we stretch that spring, the more force we have to apply, but we're not wasting that work, we're just transferring it to the spring. So the energy we use to do the work is actually equal to the amount of energy stored in the spring. So work is the transfer of energy, and yes, it's still measured in joules, and we're still going to say it's force times displacement. And so when we stretch a spring, what did we see? Well, we saw we had force over here, displacement over here, and we had a graph that was linear and went straight up like that. And so this is a linear direct proportion goes through zero graph, so F equals some constant K times some X, right? But the work done to stretch something is calculated by the area under this curve. And so the area under this curve at some distance X, area equals, it's a triangle, half base times height. Well, the base is just the displacement, and the height is F, but F equals Kx. So this becomes area equals 1/2 Kx times X, or 1/2 Kx squared, and since the area is work, okay, what we have is work equals 1/2 Kx squared. So work is the transfer of energy, and when we stretch a spring, the amount of work done is that. So this is work to stretch a spring. And now that I've stretched the spring, that energy is actually stored in the spring, which means we can calculate elastic potential energy simply by knowing the spring constant. So K is different for different springs, right? The stiffer the spring, the more force it takes to stretch it a distance, so we get a bigger K. And so K is what's called the spring constant. And it's unique to a spring, and it's measured in newtons per meter. That's not a joule, that's not a newton times a meter, that's a newton per meter, right? The amount of force it takes to stretch at a given distance. So when we take K times X, we do in fact get out a newton, it is force. So the spring constant depends on the spring, but the elastic potential energy stored in a spring is equal to 1/2 Kx squared, which is the work done to stretch the spring a distance X meters. And we get that energy out when we let the spring snap back to its original position. So this allows us to think about work in terms of energy. Work is the transfer of energy. When we did work, we transferred energy to the spring. Now, if we allow that spring to pull our hands back together, the spring is doing work on us. And so this gives us an idea of negative versus positive work. So positive work is done when energy is transferred to the object. So positive work is done on an object when energy is transferred to the object. However, negative work is when the object loses energy. Okay? So we do work to stretch the spring, we lost the energy, but the spring gained it. So we do positive work on the spring, we allow the spring to come back together. We're exerting a force opposite that, so it's still opposite motion, and that's negative work. The spring is losing energy when it does work to pull our hands back together.